Welcome everyone who is here. I hope you are managing well with the online exams, those who have started writing. I'm going to do this differently than, unless if you say otherwise, than we've been doing the engaging sessions, because at the moment I am very busy at work and I didn't realize that when I set up this, then I will have an emergency starting from yesterday. So I have been working very hard at work. So I might leave early. So that's the reason, one other reason. So, but I will try and see if at some point I can try and get you engaged into the conversations as well. Otherwise, then it will be me recording the session, but you being the participant in the recording session, because I need to finish earlier if possible. But if you have any question, feel free to ask. If I do the exercise and you want to try them, do that, and we can always get 5 minutes to do the exercises together and then move on to the next part of the session. Okay, so I had this planned out yesterday before the crisis. So I was planning to start at 11 and finish at 1, but we will see how far we get so that you get the best of the value out of the session as well as you prepare to go write your exams. So we're going to discuss normal distribution. And remember, feel free to also post your question in the chat group. And please, those who are present on the online, please make sure that you complete, you put your student numbers online as well on the chat group. And we can start with normal distribution. If you have any question, now feel free to ask. I'm just going to give you some time to ask any question if you have, so that then we can start. Okay, silence with it means no questions. So we can start with the session. In this part of the session, we're going to learn how to compute the Z-score. And when we compute the Z-score, it means we are standardizing the values that we get, so that then they can be normally distributed, and we should be able to interpret the results freely. So to do that, we first need to understand what a normal distribution is. And a normal distribution is a belly curve shaped type of a graph. It is where your mean, your median are the mean, the median, and the mode are equal. We call it a symmetrical chart or a symmetrical graph. And the location of the middle point of your graph is always located by the mean, is determined by the mean, and the spread, which means the side, how wide or how tall the graph is determined by the standard deviations. So it can be one standard deviation, therefore it means it's normally properly Bailey curved with one distribution, because a normal distribution is a curve with a mean of 0 and the standard deviation of 1. And if it's standard deviation of 3, therefore the curve might be flatter. And with normal distribution, The random variables have an infinite theoretical range of positive and negative infinity. Therefore, it means that line of a graph never touches the x-axis because the values goes up to a negative infinity and it also goes to the positive infinity. Like I said, a normal distribution is distributed with the mean of 0 and the standard deviation of 1. And when we shift the value of the mean, the graph just moves to the left or to the right. So for example, if the mean is here, then the graph will be there. If the mean, and this graph has the mean here, and the other graph might have the mean on the other side. So this graph might have the mean there. And that's what, when we change the mean, the graph just shifts from one side to the other. When we change the standard deviation, however, when we change the standard deviation, therefore it means we decrease the spread. So it means the graph might go up, it might expand up, or it might flatten up. So what do I mean? So with this one, is just the one standard deviation. If sometimes the graph might be like that. Therefore, if this is our mean, I'm not good at drawing. As you can see, let's take it from here. You can see that that is very far from that. So that will be your standard deviation. If your standard deviation, let's say it is 0.3 deviations, then your graph might look like this, where this is your mean. And you can see that the distance between that, the mean and the outside, might look so different. So the graph never touches the x-axis, so it must go like that. And that's the distribution shape of your normal distribution. And because we're working with the x observations, therefore it means we want to try and translate your x values to be a standardized normal distribution value, which means converting your x values to z values. And later on, we will learn how to use the z values to find the probabilities. And this, we do it by subtracting the value of your mean of x and by dividing by standard deviation. So we take your x observation and we subtract the mean and divide by the standard deviation. And that is the z-score. And to calculate, for example, a z-score, if x is distributed with normal distribution of mean of 100 and a standard deviation of 50, the z value for x is equals to 200 is equals to, and we remember the formula, z is equals to the x value minus the population mean divided by the population standard deviation. And we go back to our statement and we find what we're given. We know that from this statement we're given the mean and we're given the population standard deviation, and that is our x that is in the question. So we can take our values and substitute. Our x is 200, our mean is 100, and our standard deviation is 50. 200 minus 100 is 100 divided by 50 gives us 2.0. Now, later on, we will learn that a 2.0, since it's a z-score, we always have to leave it at 2 decimal. So, for example, this value should have been a 2.00 as a z-score. And when we interpret the z-score, we say that for x is equal to 200, it is 2 standard deviation because the z values are 2, so it is 2 standard deviation above the mean of 100. And we can see that it is 200 and 100, so therefore the difference between the two is just the 100. Is a two standard deviation makes 100 plus 100 makes it a 2 standard deviation away from the mean of 100. And that is the z-score. I was going to ask you to do this exercise, but we're going to do it together. Scores of high school students on a national calculus exam were normally distributed with the mean of 86 and the standard deviation of 4. What is the z-score of students that will have a score of 75? Now, knowing that our formula is z is equals to x minus the mean divided by the standard deviation, we know that our mean, which is our mu, is 86. We know our standard deviation, which is sigma, is 4. And we know that our x is 75. Therefore, we say 75 minus 86 divided by the standard deviation of 4. And that gives us 75 minus 86 divided by 4 gives us, so 75 minus 86 is 11. It's minus 11 divided by 4 gives us minus 2.75. Like I said, your z-score should always be 2 decimal places. And that's how you find the z-score. If you have any question, you can ask. Otherwise, if you are happy, then you can do this exercise. Remember, you are also being given the variance. Sorry, my thing keeps on going out. You are given the variance, you need to find the standard deviation. Therefore, it means you're going to also identify what you're given. You are given the mean, you are given the variance, which is sigma squared. And we know if I'm given sigma squared, I can find the standard deviation by taking the square root of the sigma squared. Therefore, it means I need to find the root of 16, which will give me my standard deviation, which will be square root of 16 Okay, so the square root of 16 is 4. So that is what you're going to substitute into the formula. So to substitute, our x is always given in the question. So our x, ignore where it says the probability, we just need to find the z score. So our z, find the z score as well. Sorry, I should have removed the probability on this question. Our x is 90 minus the mean of 86 divide by our standard deviation of 4. So this will be 90 minus 86 divided by 4 equals 1,00. Remember to leave it to 2 decimals so that you don't get confused. Exercise 3. Remember also you are given the variance on this. Okay, so we know that the standard deviation is the square root of our variance, which is sigma squared, which is the square root of 16, which is equals to 4 that we have done previously. We know that is our mean, our mu, and this is our variance, and this is our x. So we can substitute into the formula, which is 80 minus 86 divided by 4, which gives us 80 minus 86 is minus 6 divided by 4, which will be minus 1.50. And that's how you find the Z score. Is it 1.25? Don't go find the probabilities as yet. We're not yet there. We're still doing the Z score. And that's how you find the Z scores. Any questions? Any questions? If there are no questions, then we can move forward. So now we're going to learn how to use those Z scores to calculate the probability or to find the probability on a Z normal distribution. Now, we're going to also learn how to use the normal distribution table. First, we're going to look at how to compute the probabilities for a normal distribution when we are given probability, when we have to answer the question, what is the probability for z, for x less than a value, where we will have to find the probability of z less than a value. So how do we do that? So first we need to understand how do we even find that and what does it mean? Finding the normal probability, which is the area underneath the curve. So if we look at this curve, we can see that it's a normally distributed belly-shaped curve with a mean of 0 and the standard deviation of 1. I'm going to call it that way because it's normally distributed. If A is the value less than, therefore it is this value here is our A. We want to know what is the probability of A less than. So we're going to use the normal distribution probability table, which gives us the value of a less than. So how do we then use this table? The table looks like this. The table has the less than, and it also have, it has the negative side, and it also have the positive side. So if the answer of your z value is negative, then you go to the negative side of the table. And the negative side of the table always contains the smaller probabilities. Because it's on the side of the negative, it will have the smaller side of the probability. And if we look at this table, you will see there that we have small values in terms of the probability, because the probabilities are these values inside the table. Your z values are those values on the side and also at the top. Now we're going to learn how to read this table. Also on the positive side, if you look at this, the positive side has the bigger probabilities because the area underneath the curve, it is that bigger side of the probability side of the table. The z values are positive, as you can see, and we're going to read the z value from the left and from the top. Let's learn how to read this table. So let's say, for argument's sake, we had 2.00, and that was our value. So the value of our z, we're going to assume in this instance that we calculated this value from the probability, and we calculated the z value, and we were finding the less than value, and the value is 2.00. So if this is the case, then we need to know how to read this from the table. To read this, we're going to take the first two digits, one before the comma and one after the comma, and we go and find it on the side. The last digit will be represented by the last digit of each value at the top. You find on the left, you find on top, like Cremora. It's always on top. So the first two digits, one before the comma and one after the comma, you're always going to find it on this left-hand side of the table. And the last digit, you're always going to find it at the top. So let's read this. 2.0, we're going to have to find 2.0 on this side. So now we don't have 2.0 here. Now it forces me to change my value. I'm going to change this to 1.00 now. I'm going to change it to 1.0 because I do have 1.0 on this side of the table. So I'm going to look for 1.0 here. It's my 1.0. That is the value on the left. And then I must go to the top and look for the value that ends with a 0. And that is the value that ends with a 0 there. Therefore, it means it is this column that I must look at. And where both these two columns meet, the left and the top meet, that is my probability. Therefore, my probability is equals to 0,8413. And that's how you read the table. So let's change things. Let's say we were looking for the probability of z less than minus 2.01. Let's say this is our probability we're looking for. So remember, the first two digits, these two digits with a sign in front. So it means all these digits, the sign plus the two digits, the one before and the one after, these two, we're going to find them on the left, on the negative side of the table. And the last digit, we're going to find it at the top. This, we're going to find it on top. So minus 2, we're going to look for minus 2. Oh, I always choose the values I don't have on the table. So let's change it to minus 3. The value is minus. Let's make it minus 3,01. So we come here, we look for minus 3,0, which is that value there. And we go look for one last digit at the top, which is this column. So where they both meet, and this probability is equals to 0,00113. And that's how we read the normal distribution table, especially when we're given the less than values. Let's look at this example. Let X represent the time it takes in seconds to download an image from internet. Suppose X is normally distributed with the mean of 18 and the standard deviation of 5. Find the probability that X is less than 18.6. To do that, we're going to use the formula to calculate. So our Z, it's X minus the mean divided by the standard deviation. This is the Z-score calculation or formula. So we know that the mean is 18, the standard deviation is 5, and the X value is less than 18. So therefore, we can substitute. X is 18.6 minus 18, which is the mean, divided by the standard deviation of 5. And when we calculate this, we get 0,12. So since we have the Z-score of 0,12, therefore it means we can go to the table and go look for this probability. So let's see if our table has 0,12. So yes, our table has that. I'm just gonna clear this. So we know that we're looking for 0,12 on the positive side of the table. So we're looking for the probability that Z is less than 0,12. Coming to the table, we look for 0,1 on this side, 0,1 from this side of the table, and at the top we need to look for 0,02 because we're interested in the last digit, which is this column and that row. So when they both meet, which is at this point, that is our probability of a less than. Therefore, our Z less than 0,12 is 0,5478. I go back. And that will be the probability of Z less than 0,12. Any question? If there are no questions, there is your exercise. Remember, you can first find your Z value. And this question is asking you to calculate the probability because this is the exercise we're doing. And for the sake of time, we can also use the less than probability. shit, sorry, I'll have to go back. Sorry, guys. I didn't see that I am muted. Okay, just to repeat what I just said, because I was muted. First, I identified what we have. We have the mean, we have the variance. So we need to find the standard deviation, and the square root of 9 is 3. And we are given the x value, which is 3.5, and you substitute onto the formula and calculate. And once you are done, you go to the table and you find the values. I am sorry about my muted mic. Next time I'm muted, please, because when I move the block where it has the functions, my computer is a touch screen, so when I move it anywhere I touch, it touches things that are not supposed to touch. So let me call it out so that I can pick it up immediately before I can go to the chat, because when I get to the chat, it's already too late. So next time, do it as quickly as possible. Okay, so here is your exercise. And to pay for my sins of not unmuting my mic, I will do this one for you as well. The mean, which is the mu, is 86. We are also given the variance, which is sigma squared. So therefore, it means sigma squared. We can find the standard deviation by finding the square root of 16. We've done this before. We know that it is 4. And we can find the probability of z less than, our x is 80. So therefore, probability of x less than 80, we can find it by using the z value of less than our x minus the mean divide by the standard deviation. Therefore, the probability of z less than 80, which is our x, minus the mean of 86. We've done this before, so I'm not going to explain more on this. I'm just going to go to the answer. 4, then this is the probability that z is less than, and we've calculated this earlier, and we find that it's less than minus 1.50. Now we go to the table. We go to the table, we go look for minus 1.4 on the table, 1.5. So minus 1.5, it's somewhere in there. And I know that I'm looking at the first column as well. So I'm going to take it up a little bit so that I can go to minus 1.5. And I know that this is the column that I'm looking at, because it's 0.0. This is not too visible, but I think I can make it out. It's 0.0668. And we go to table, 0.0668, which is option number 3. And you can do the last one. We also did this earlier. It was 1. The answer for that z. So we did this with the previous exercise. Our z was less than z x less than 90, with the probability of z less than x minus the mean divide by the standard deviation gives us the probability of Z less than 90 minus 86, and that's what we did in the previous one, and we are given the variance, so the standard deviation will be 4, and the probability that Z is less than 1, 0, and you can go and find that probability. I'm not going to go to the table. You go to the table and tell me what is the probability. We did this. And yes, Magdalene or Magdalene. I keep on calling you Magdalene. And Deirdre, the answer is 0.8413. I am going to give you 10 minutes so I can also check my emails from work to see if there's nothing urgent that they require from me at the moment, since I told you in the beginning. I will have to excuse myself from time to time. So just take this 10 minutes that is left. We'll come back at 12 o'clock exactly, and then we can finish with the second part of the session. hope everyone is back and we can continue. Okay, now we're going to look at the probability of more than, greater than, at least. Which means we're going to do things differently. But we will still use the same concept when we compute the probability from a normal distribution when we're looking for the probability of Z or X less than, X greater than, which means we will have to find the Z scores of a greater than a value. When we find the probability of a greater than, remember the table contains the less than probabilities. So therefore it means if you look at the shaded graph, the probability that will be measured underneath the area, underneath the curve, will be this red area. And the table contains the white shaded area, which is the probability of the less than. So if the table contains the probability of the less than, therefore it means when we find the value on the table, we always have to minus that value from 1. So we're going to say 1 minus the table value, not the Z score, but the table probability value, so that we can get the small shaded area on the side. Even if it was on the negative side, we will be getting the bigger side of the area, but we will still be using the less than values because we will be using the values on the table. So we must get that clear. The values that you see on the table are the less than values. That is why when we calculate the probability of the less than, we always take the value we see on the table. So when we calculate the probability of more than or greater than, then we're going to subtract 1 from the value we find on the table. Let's look at an example. This is the same as what we have done previously, but we just changed the sign. Previously it was less than, we changed the sign to a greater than. We find that we calculate the Z, and we have calculated it previously. That's why I'm not repeating the whole thing again. And we find that the probability, the Z value was 0.12. Since it is greater than, we're going to say 1 minus the probability of the value we're going to find on the table, which are the less than 0.12. And we go to the table, we go and find that probability, and we did find that probability was 0.5478. We subtract that from 1, and we get that that probability is 0.4522. And that is how you find the probability of more than or greater than. Let's look at more examples. Find the probability. What is the probability of student that will have a score greater than 80? We're also using the same example that we used previously. So we know that our probability, I'm not going to repeat all this, we did them in the very first set scores and all that. So we know that we're looking for the probability of greater than 8. Therefore, we calculated this and we find that it was Z greater than minus 1.50. Remember that? We calculated this, 1.50. To find this probability, we need to say 1 minus the probability of Z less than or equal, or Z less than minus 1.50. 50, so that we know that we're going to go to the Z table to go find this probability. And we know that because we did go and find that probability, and it was 1 minus 0,0668. That's the probability we found on the table. And we can calculate it. 1 minus 0.0668 is equals to 0.9332. Please ignore all this. This was typed wrong. It was supposed to be option number 2. If I must go fix this light as well. This was supposed to be 0.99332. It's a typing error. So it would have been option number 2. Sometimes in the exam as well, they will give you questions like this. Already they have calculated your probability and your Z score. So they already calculated your Z score. All you need to do is to find the probability. So it means you just need to go to the table and go find the probability. Whether it says greater than or equal, or whether it says greater than, they mean one and the same thing on the normal distribution probabilities. So use that value and go find that probability on the table. And to find that probability, you go to the Z table. So we're looking for the probability. Let me clear all this. We're looking for minus 2.88. That's the probability we are looking for. So if I expand this, okay, it don't fit. So, but we are looking for 2.88 minus 2.88. So we go to the Z distribution on the negative side of the table. We look for 2.8 and we look for 8 at the top where they both meet, which is the second last. And it's 0.0020. And that will be option number 1. No, it's not option number 1. That's not the right option. It's not option number 1 because it is the greater than. So we're going to say 1 minus the value we find on the table, which is 0.0020, which is equals to 1 minus 0.0020 equals 0,9980, which is option number 4. Which is option number 4. The next exercise. Okay, so to find the probability that x is greater than 145, we can calculate it by saying the probability of z is greater than x minus the mean divided by the standard deviation. Our mean is 100. Our standard deviation is 20. Our x is 145. So we're going to say the probability that z is greater than our mean and our x. X is 145 minus our mean of 100 divided by our standard deviation of 20. And that gives us the probability that z is greater than 2.25. We go to the z table, and when we go to the z table, it means we're going to find the probability that z is less than 2.25. And when we go to the table...
Hi, Elizabeth. I can see your slides. I don't know if it's me only.
Go out and come back in.
Okay.
When we go to the table, can you all see the table? And we go to the positive side of the table because we're looking for 2.25. On the positive side of the table, we go look for 2.2, and we go for 5 at the top, and the answer is 0.9878. So it will be 1 minus 0.9878, which then it means it's 1 minus 0.9878 equals 0.0122. In the exam, you need to be very careful when you choose your options and your answers, because you can see number 3 almost looked like our correct answer, but it's not. Your next exercise.
Sorry again. I only see Magdalene DM on the screen.
Are you sure you don't see the slides?
The only picture of Magdalene DM on the screen.
Did you go out and rejoin the meeting?
Yes.
Okay, let me do this and you will tell me if you're still not seeing the presentation.
Okay.
And now? Are you now seeing the presentation? Hi. Are you now seeing the presentation?
No, I'm still seeing her.
Are you using your phone or a laptop?
I'm using my phone.
Okay, you need to close, go out of the meeting and rejoin the meeting again. Okay, so we're going to find, we're going to find the probability that X is greater than 17.5. Therefore, we're going to find the probability that Z is greater than X minus the mean divided by the standard deviation, which our mean is 10. Our standard deviation is 3. Our X is 17. So we can substitute Z greater than 17.5 minus 10 divided by the standard deviation of 3. And we'll give you the P. Z is greater than 17.5 minus 10 17.5 minus 10 divide by 3 gives me 2.50. 1 minus the probability, because I'm going to the table, I'm going to find the probability of the less than 2.50 so that I can get the greater than probabilities. And when you go to the table, 2.50, it's in the positive side. We go to the table. We'll look for 2.5. I know that I'm looking at this column of zeros. So even if I go up on the table and it disappears, no problem. I've already highlighted the column I need. And 5 is there. So the answer is 0.9938. That would be 0, oh sorry, 1 minus 0.9938. 1 minus 0.9938 equals. Now, if you're having a Casio calculator, I think on the sharp calculator, it should be fine. You should have all the digits with the 0, but if you have a Casio calculator and you get a number which has a power of a -0, a negative number, like it has 6.2 times. So the number that I'm looking at right now, it looks like this, 6.2 times 10 to the power -3. That's the number that I'm looking at in front of my calculator on my Casio. The easy way, if you can remember this, let me give you 2 options on how to remember how to get this to a decimal number. Is to add 1 to this value. So it's just press +1 in your calculator and it will say 1. So because you're adding 1, it will say 1,00. And remember you added 1, so you can ignore the 1 and replace it with 0, and it will be 0,0062. Alternatively, because it's -3 and it's 6 point, so it says there is 3 zeros, 1 before and 1 and 2 after the comma. So if there are 3 zeros in front of 6.2, so the first 0 will be in front and the 2 zeros will be after the decimals. If it was to the power of -4, then it will be the first 0 and the 3 zeros after the decimal. So you can always remember that the 3 zeros are represented by that negative. So this is 0,0062, which is option number 2. And any question? Any question? If there are no questions, then we can move to the next part of the session. which is looking at the probability of between. Okay. We're going to learn how to compute the probability where x lies between the two values, where we're going to find the probability that the z value lies between the two values, a and b. So if we recap on what we did, we said for the value of the less than is the value that we find on the table. If it's greater than, then it is 1 minus the value we find on the table. For between, it works a little bit different. To find the probability of between, because we're looking for the between values, only this small shaded area between from that distance to that distance. It might have been from that distance to that distance, but we're looking for that between, not the whole underneath the area from up to the negative infinity or the positive infinity, but just the area in between. To find that, we can find the probability of the highest value, which is the B value, and subtract the probability of the A value from the tables. So we'll take the table value from the B and minus the table value from A. Let's look at how we do that. Suppose X is normally distributed with the mean of 18 and the standard deviation of 5. Find the probability that X is between 18 and 18.6. To calculate that, we can use the Z and calculate the Z for 18 and the Z for 18.6 separately, and then bring them together at the end. So we do that. Our mean is 18, our standard deviation, and our X values are those two values. So we start with the 18. 18 minus 18, divide by 5, give us 0. And we do the same with 18.6. 18.6 minus 18, which is our mean, divide by 5, which is our standard deviation, and we get the value of 0.12. Now we go to the table. When we go to the table, using these two values, therefore it means we're going to find the value for 0 and the value for 0.12 on the Z table. Remember, when we find the probability of a Z between, we said to find the probability where Z lies between A and B, we're going to minus the probability that Z is less than B, which is the value from the table from B, minus the value we find on the table from A. So when we go to the table and first find the value of Z less than, which is the probability of Z less than 0.12, we go and find it 0.1 and 2, and that is the probability 0.5478. And we go find the probability of Z is 0.00, which is 0000 at the top, which is 5. Yes.
I'm sorry to stop you again.
Yes.
This thing, it tells me that I'm connected to Magdalene, and I don't know connected how. So the only thing I can see is her because I'm connected to her.
I also don't know because everybody else can see unless...
It's not possible maybe that she can disconnect from her side.
Let's go here. Who are you on here? What is your name?
LM.
LM.
Yeah.
Let me see if please don't disturb my Leshidine.
Yes.
I'm going to make you a presenter for now. Please don't change anything.
Okay.
Tell me if you can see the presentation now.
Nope.
You still can't.
I'll just check the recording later then.
Okay, no problem.
All right, thank you.
Okay, let's continue. So I was explaining that we go find the probability on the B side, which is 0.12. We go find it, it's 0.578. And we go find the probability of the A value, which is 0, which is 0.00, which is 0.50. And we subtract one from the other, and we get the probability of 0.0478. And that's how you find the probability of between. Let's look at more examples. Suppose X is normally distributed with the mean of 18 and the standard deviation of 5. Now we're looking for this shaded area, which is between 17.4 and 18. So to find that probability, we can calculate the Z for both of them. So when we calculate the Z, X minus the mean divided by the standard deviation for 17, we get 0.12. If we calculate the Z for 18, we get 0. So we take this and we write it as the probability of Z less than A minus the probability of Z less than, Z less than B minus the probability that Z less than A. Remember that? We write it in that manner. So we take 0 first, so the probability of Z less than 0, and we do the probability of Z less than 0.12. We go to the table. For Z less than 0, we find that it's 0.00. When we go to the probability of Z less than 0.12, we find that the value is 0.4522, and that 0.05 minus 0.4522 gives us 0.0478, and that is the probability of between the two values. Is your exercise. You don't have to go calculate the Z scores. They've already calculated them. All they want you to do is to find that probability. Therefore, remember, when we calculate the probability, that Z lies between A and B. We find it by using the probability that Z less than the B value minus the probability that Z less than the A value. Yes. So when we go to the table, we're going to find the probability that Z is less than 1.9 minus the probability we're going to find from Z less than minus 1.1. When we go to the table, we find that the Z less than 1.9 is 0.9713 minus the probability in the negative side of the table, 0.1357, which then gives us 0.8356. And that will be the probability of between. Is your exercise. Okay, so to find the probability of between, we can find it by using the probability that Z or X is between 71 and 82, which we can find. I'm going to write at the bottom here the probability that Z lies between the two values of X minus the mean divided by the standard deviation, X minus the mean divided by the standard deviation, which then is the probability. If I substitute the values, this will be 71 minus 76 divided by the standard deviation, which is 10. Which is 10 and 82 minus 76 divided by 10, which then gives me the probability of 71 minus 76 divided by 10 will be minus 0,50, and 82 minus 76 will be positive, and it will be 0,60. And therefore, we're going to find on the table the probability of Z less than 0,60 minus the probability of Z less than minus 0,50. And if we go to the table, the probability of Z 0,60, it is 0,7257 minus the probability of minus 0,50 is 0,3085. And the final answer, when we subtract one from the other, the answer we get will be 0,4172, which is option number 5. And I think this will be the last question we do, and then it will be the end of the session. Okay, so with this, similar, we do the probability of X lies between the two values, which lies between 80 and 90. And therefore, we can find the probability that Z lies between X minus the mean divided by the standard deviation, X minus the mean divided by the standard deviation, which then gives us the probability that our X is 80 for the first one. $80 minus our mean of 86 divided by our variance, which will be the standard deviation. Remember, the square root of 16 will give us 4, which this is our standard deviation of 4 that lies between 90 minus 86 divided by 4, which we've calculated this before as well. We know that 80 minus 86 was minus 1.50 less than z less than. For 90, it was 1,00. And since we already found those probabilities, I can just substitute them. Probability of z less than 1,00 minus the probability of z less than minus 1,50. And there's 1,00. We have been using this, and it's 0,8413 minus the probability of minus 1,5, which is 0,0668. And that gives us 0.8413 minus 0.0668 gives us 0,7745. 0,7745. Please ignore those options unless if I typed something wrong or I found the probability of something wrong. So let's just double check the probabilities. So the probability of 1 we've been using 0,8413, that's the probability of 1, and the probability of minus 1.5 is 0,0. I think also here there is a mistake with this option. It should have been 0,7745, not 0,0745. Is typing errors. So it means also those exam papers, they had an errata in them as well, then probably. Or assignment. This is slide number 40. I would have to go and fix that. Any questions? I just want to do one last thing with you guys. Let's say I'm going to pick one question from the previous ones that we did so that it makes it easier. Let's say I'm going to use this one. Let's say we know that the probability is 0,125. So I'm going to 0, that. I'm going to rechange this, erase all questions, all ink. I wanted to erase all the ink. Oh, sorry, I need to go discard everything. I need to use this question, and I'm going to duplicate it. Just bear with me for some few minutes because we didn't cover this in the previous sessions that we had. So if I duplicate this, I'm going to move it right at the bottom. And I'm going to call it let's go find X. What is the value of X? question, and we are given that the probability of x greater than x, not the big X, a small x, the probability of x greater than the small x, if that probability is 0.0062. What is the value of x? And those are the questions, typical other questions that you might encounter in the exam, where they give you the statement. You can ignore the answers that we have here as well. So this won't be applicable anymore. You can just delete them. So the question is, suppose x is normally distributed with the mean of 10 and the standard deviation of 3. What is the with the probability that x value is greater than a random value of x, which that probability is equals to 0.0062. What is the probability? What is the value of x now? The key thing here is the sign as well. Remember, the sign tells you how did they find that probability. Something went wrong. I can't write on the anymore. I'm unable to write again. So the key thing here is to find how they found this probability. And because of this sign, we know that when they found this probability, they used 1 minus the value they found on the table. In order for us to find that x, we need to find the value, the z score. So we need to work backwards from here. So we know that the probability of z, let's say that is the probability of z greater than x value, or the x value is the value that we're looking for, or the value of a, let's call it the value of a, because we're looking for the x. So we're looking for the probability that x is greater than, what am I writing now? X is greater than the value of small x. And we know that to find that value, they use the probability of z greater than a in order for them to find that probability, which is 0.0062. So if we know that, we can work backwards because we know that we're looking for that x value. So we know that to find this value, this actually was 1 minus 0.0662 will help us find the value of our z. That's what we want to find, the value of our z. And this will help us find the value of our z, because once we find this probability, we'll go to the table, we'll look outside. So let's do that. So using this, we can go find, and we know that this was 1 minus 0.0062 was 0.9938. So it's very helpful. So we go to the table. I'm going to keep this. We go to the table, we look for 0.9938. 0.9938. When we have that value, we go outside the table. So we go out, we find 2.5, and we go to the top, we find the last value is 2.50. So it means our z value that corresponds to this probability was our z and take it back to a presentation mode. Our Z value that corresponds to this probability is 2.50. So now we can work it back. So since we found our Z value, so we know what the value of Z is. So we can go back and say our value of our Z. So we can, without putting the probabilities, we're going to change everything and put it in this manner. I don't even have to put the greater than sign because I've already found what my value of Z is. So I can always use my Z score. So I know that my X minus the mean divided by the standard deviation. I am given the mean, which is 10. As the mean, I'm given the standard deviation, and I am given the probability, which I went and found the Z value. So now we can substitute all the other values so that we can find our X. So to do that, our Z is 2.50 equals our X, which we don't know what the value is, minus our mean of 10 divided by the standard deviation of 3. And this we can multiply 2.50 multiplied by 3 because we cross multiply, and this will be X minus 10, and that will give us, on the right hand side, it will give us 2.50 multiplied by 3 gives us 7.5, and if I take 10 to this side, it will be plus 10, which means X is equals to, so therefore our X will be equals to 7.5 plus 10, which gives us 17.5. And that's how you work it backwards. And that is 1. If it was a less than value, the value you see on the probability, so if the probability was the probability that X is less than X is 0.0068, the value we see here, we go find it on the table and it will give us the Z score. We don't have to say 1 minus because we know that how they found that probability of Z less than X, it will have been the same as that value on the table. And that is how you work backwards. You can also find the standard deviation if they didn't give you the standard deviation. Or you can find the mean if they didn't give you the mean because they would have given you the population standard deviation, they would have given you the X value, and they would have given you the probabilities. Then you can go find the Z value and substitute and find whatever is missing from the equation. And that's all what I wanted to share with you for today. And thank you for participating and writing up your answers and making this interactive in that manner. And this is the last. I just want to also say thank you and all the best with your exams. I will ask UNISA to replace the original session 3 video with this video so that then you can have a full recorded video instead of having a new set of videos. I thank you for being here and all the best with your exams. Thank you, guys.